Hi everybody, it's Miss McCall for Miss McCall and Mr. Fanto's physical science class. And we're going to talk about the periodic table of the elements, how to use it, and how to draw Lewis dot diagrams. From the last module, I have my periodic table colored. I selected yellow for the nonmetals, blue for the metalloids. I colored my metals red, including the lanthanide and actinide series. And then I colored the noble gases orange. It doesn't matter what colors you used. I also followed the directions and put the valence electron numbers at the top of each of the columns. And for this class, we mostly focus on the first three rows or periods. And then, of course, the valence number belongs with the columns or groups on the periodic table. All right, so looking at the diagram or the document that I placed with this module for the Lewis dot diagrams, first of all are some definitions, kind of review. So I'm going to let you guys look up this first page. We've got some fill in the blanks and some definitions. Picking up here in the middle of the page, I'm going to help you fill in a few of these blanks. In a neutral atom, the number of protons equals the number of electrons. In a cation, one or more electrons so a cation has a positive charge, so that means one of the electrons is lost, giving the atom a positive charge. In an anion, it has a negative charge, so that means one or more electrons was gained because it got an extra negative charge, giving it a negative charge. And we'll talk more about that next week when we talk about how atoms bond. But for right now, we're going to just focus on the elements themselves from the periodic table. So the first thing we're going to do is fill out a chart with some of the details from the different elements, and I'm just going to pick one. I think I will pick chlorine, and we'll fill out the information using the periodic table. So chlorine, I see on my periodic table, is number 17. Symbol is Cl. Chlorine, and then I have a number 35.4527. So I'm going to use that information to figure out what goes in the blanks. For chlorine, the atomic number, being that top number, is 17. That means 17 protons. The atomic mass is the average number of protons plus neutrons, so it's how much mass is in that atom is this number listed here. So it's going to usually have, or I guess always have, decimal points after it because it is an average. So 35.4527 is my atomic mass. So this is the number that I've got to figure out a little bit. The mass number is protons plus neutrons. So that means that in one individual atom, it's the number of protons plus the number of neutrons, so it can't be an average. But most of them will have a mass number. If I just, this is where I want to round, most of them will have a mass number of 35. Okay, the number of protons, I use the atomic number, that's 17. For neutrons, you might want to make a note here like you did on the periodic table. Number of neutrons is mass number minus atomic number. So this is going to be mass number minus atomic number. So in this case, that would be 35 minus 17. So that is going to be 18 neutrons. For the number of electrons, because it has a charge, a negative charge, and the protons have a positive charge, the number of protons and electrons will be equal. We're assuming all of these are neutral elements, or excuse me, neutral atoms. And so the number of electrons equals protons, so that will be 17. Right, if you guys will please fill out the rest of this page, and you can send me a photo for your submission. You can also fill this out electronically. All right, page 2, you don't have to do anything on page 2, but this is a review from the last module also, thinking about ways to visualize the atom. One thing that we will focus on here is not really the current model of the electron cloud, even though that's the accepted model, because we know that the electrons are just flying around out here. And so it would be kind of like how a fan blade goes around and it appears to be almost like a solid structure because they're moving so fast. But the Bohr model can be a little bit more instructive sometimes, because we can kind of think about those electrons hanging out in certain areas at certain energy levels around the nucleus. So we know the positive and the neutral charges, the protons and the neutrons, are in the nucleus, and the electrons are flying around outside. So for the Bohr model, we could actually do a drawing based on what we know about the different elements.